Good morning, friends. Welcome to GoOnlineTrainings.com. So, yesterday we spoken about what is a star schema and what is a snowflake schema and what is recommended, what is not recommended, and what is a normalization, what is a denormalization. Lot of things we discussed. Star schema is always recommended, which is very faster to read the data because it is a denormalized schema architecture. And Snowflake schema will have more tables. Normalized concept is applied over there. So more, tables means more joins. More joins means reading is very slow in case of Snowflake schema, right? So, but in the data warehousing, we need to have more speed. Reading speed should be very, should be very fast. But unfortunately, when you have a snowflake schema, it will become very slow. Clear? Whether it is a star schema, snowflake schema doesn't matter now because there is a concept called SSAS, right? When you have SSAS concept, so you can make it very faster. So whether you are using a snowflake schema, star schema, no problem today. So if you wanted to increase the performance of the data warehousing, there is one more concept called SSAS, SQL Server Analysis Services, where we are going to be creating a lot of cubes. Cubes are two types. One is called a multi-dimensional cube. The second one is called tabular model cube. So even though you're using a snowflake schema, and even though the data reading is very slow, but when you create a cube on top of the data warehousing, automatically the reading will become very faster. So that is the need for the cube actually. Clear? So why cubes are implemented, we're going to be understanding later. But as of now, if somebody asks you why cube means to process the data very quickly, even though you're having star schema, snowflake schema, doesn't matter. But if you create a cube, definitely you will get high performance processing is going to be happening. Clear? So we'll discuss about cubes also later. So let us leave the cubes part as of now. Yeah, am I clear? So let us concentrate on a few more data warehousing concepts today. And the most important concept is in many interviews, people are going to be asking what is a star schema, what is a snowflake schema, when to use what, and what is a schema you are using as part of your project, and what are the dimension tables you have, what are the fact tables you have, how the dimension table are linked to the fact table, and tell me some of the dimension table names, then tell me some of the fact table names, and how are you loading the data with the help of SSIS? What are the real-time challenges that you're getting when you load the data? What kind of a reports you have created? So all these things are going to be asked. Clear? To fulfill this, we are planning to start new project on MSBA as well as Power BI. If you're interested, you can enroll. So there are two time slots. One is 6 p.m. India time, 6 p.m. evening time, so that is one time slot. And the second time slot, I don't know whether morning time, we don't have any time as of now. But if you need, we can plan for morning time as well. Okay. So very soon you're going to be getting the schedules and the broadcasting messages for the, major project. So 30 days it will be daily you need to work minimum 2 to 3 hours. 3 hours minimum you need to work. So 3 into 30 into 3, 90 hours of project. Very in-depth project. So we're going to be having SSIS, SSAS, SSRS, and Power BI plus data warehousing plus equals our store processes. Lot of things are going to be covered there. End-to-end project. Okay. It is a major project that you can use. So the schedules are going to be announced very soon. It is completely hands-on driven. You don't expect 1 hour of theory classes. Only 10 minutes of theory will be there. Then I will give the task. Then you need to work on this. To work on that, you need to have 2 hours or 3 hours per day. Otherwise, you will not be able to complete the project within a month's time. Okay, it is very, very good project. The same project you can keep as part of your CV as well. People who know SSIS, they can start. If you don't know SSIS, don't join and don't ask me, sir, I don't know SSIS. Can I start a project? I'm telling you right away, no. Okay, so again, don't ask me the same question, right? If you know SSIS, you can start. Yeah. Now, the next important concept is we have dimension tables and factor tables, and we have types of dimension tables and types of fact tables, right? We have dimension tables and fact tables as part of data warehousing, and we have types of dimensions. Role-playing dimension. Dimension means a table which is going to be storing a textual data, string data. Conformed dimension, junk dimension, degenerate dimension, slowly changing dimension, rapidly changing dimension, infer dimension. There are thousands of varieties of dimensions are available as part of your data warehousing. Clear? Very, very, very important interview question. So do you know what is a junk dimension? Do you know what is a role-playing dimension? Do you know what is a degenerate dimension? Do you know what is a rapidly changing dimension? Blah, blah, blah. Clear? So that is what is. What is the question? So after SSIS, can you start another project? Yes, yes, we'll start. Every month or every once in a 2 months, we'll start the project. Once SSIS is over, we can start. Sir, after SSIS, can you start? What is the question somebody asked? Why star schema will contain redundant data? Redundant data means, I told you, right? So you have the same columns like this, right? So if you see, why star schema contain redundant data? So that is the question asked by Tirumala. Okay. So it is like this. When you create a dim product table, you see a lot of duplicates here. Have you seen? Soaps, food and beverages. So it is more duplicate and redundant data. So it is also redundant here, but when you have small numbers, it is also duplicate 40 and 40 and 10 and 20, 10 and 20. So it will not look like a redundant data, but it is when you keep like this, it is a duplicated data. It is redundancy. Redundancy means duplicate. So denormalization will have a lot of duplicates, lot of redundancy. Even though OLTP also will have a lot of duplicate. Without a duplicate, it cannot work. But it will not look like that. Okay, it will not look like there is no redundancy. It is also there is a 40 and 40, 20 and 20. But when you see this data, it look like more redundancy here because spellings are bigger and it is more visible to you. So when you merge the data, you will have more and more redundancy. It'll show like this. Clear? If you keep the data, it will be like this. Only the numbers are getting duplicated, but original data is not getting duplicated. But here the original data gets duplicated. Okay. Yeah. So what is star schema? Star schema means you need to have two tables data into one table, and that table you directly connect to the fact table. Yeah. That is what is the answer. So the next questions they asked, why fact table should not have incremental loading? I'll talk about this. So Sai Tejaswani asked. So if you know SSIS, I will answer this. That is also a beautiful question. Many people are going to be asking that. Why? I'll tell you very soon. Or if not, by tomorrow, I'll tell you. It's very, very important. And I discussed in previous class videos as well. One second, but we will discuss that question. Okay. Why factor tables are not implemented with the incremental loading? Why only dimension tables will have incremental loading? Why not fact? So that is the question. Okay. So the answer I will tell you very soon. Now, today I'm talking about different types of dimension, right? What is a role-playing dimension? So, if you see any dimension table and a factor table is having more than one relationship. So, I have a date key is a primary key, which is linked to sale date key is one foreign key. I have the same date key linked to delivery date key. So this is one more foreign key. If any dimension tables and factor tables. One minute, guys. If any dimension table and a factor table is having more than one relationship. Okay, so this date key is linked to sale date key, and the same primary key is linked to this. There are two foreign keys. So this is acting it twice. If somebody acting it twice in the movie, what you will be calling? Hare, that guy is playing different roles in the movie, yeah? So which one is playing different roles here? Date key will become a sale date key. Date key is also pointing to delivery date key. So the dim timetable is called as a role playing dimension table. So one hero is acting multiple roles in the movie. Okay. One name is called Peter, one more name is called Ajay. So, or Salman. If somebody is playing dual roles means that guy is you can say he's playing different roles is playing. Clear? So according to data warehousing, if any dimension table and fact table is having more than one primary key and foreign key relationship, then the dimension table is called as role playing dimension table. Dimension means a table which is having a textual data or a string data. Clear? So dim timetable is going to be a role playing dimension table. Very, very, very important interview question. So what is the answer? Answer is, if the dimension table and factor table is having more than one primary key foreign key relationship means the dimension table is called as a role playing dimension table. In our diagram, so we have sale date key, delivery date key is pointing to this. That's it, nothing else. The next one is conformed dimension. So conformed dimension, it relates to multiple factor tables within the same data warehousing. Dim date is a common conformed dimension because its attributes day, week, month, quarter, year have the same meaning when they join to any factor table. For example, I create, see, it is any conformed dimension relates to multiple factor tables. If you don't have a multiple factor tables, conformed dimension is not going to come. Okay. Conformed means there is no meaning. There is no other meaning. That is the there is no other meaning. It is everywhere same meaning. So that is the point. So conformed means there is no other meaning. So wherever you use, the meaning is the same. For example, I'm using a dim timetable. It is a linked to fact table, fact expenses. The same table is a linked to fact sales. So whether I'm using it here or I'm using it here, if I say year means year number. If I'm say semester number here, it is the same thing. It is also same thing. If I'm say day number, this is also same meaning here. Day means here also same meaning. Clear? If any dimension connected with the multiple factor tables and the meaning is the same everywhere. So if I say semester means it is a semester here also, it is semester here. If that is not the case means, so this is not a conformed dimension. For example, I will give you one beautiful example. Okay. Now let me give you Excel sheet. I have one date key. I have some full date. I have some, year number, blah, 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 semester number, and a quarter number. A lot of things are there. Month number, right? And month name, and I have day number, week name, blah, blah, blah. I have. Now, there are two things you need to understand here. One is called calendar month. Okay. One is called calendar month. And one more is called fiscal month. What do you mean by fiscal? It is a fiscal calendar, means financial calendar. Fiscal month. Okay. So one is called calendar month. The other one is called fiscal month, financial calendar month. Like that, we have calendar quarter and we have fiscal calendar month. So what is the difference between this? Okay, now let me take 1 month. If I say January, it is everywhere 1. February, everywhere 2. March, everywhere 3. April, in all over the world, it is in a 4. So there is no problem here. So the meaning will not change. June, it is 6, like that. July is 7. So there is no change at all. Okay. So this is what is called calendar year or calendar month. Okay. So calendar month everywhere the meaning is the same. But what about financial? You have a September is 9, October is 10, November means 11th month, and December means 12th month, right? So when you say 1 means January everywhere, so that is the meaning I'm talking about. Okay, if I say January here, it is 1. If it is January, it is 1. But according to India, the financial year will start. So financial year is going to be starting. So that is what is called fiscal. Fiscal means financial calendar. Fiscal calendar month. So according to India, what is that? Fiscal month is, so January is not the first month. We are going to be starting with April. So according to this, this is April. This is the first month. Second month, third month, fourth month, fifth month, sixth month, seventh month, eighth month, ninth month. Then this is what is called a 10th month, 11th month, then 12th month. Now, according to India, this is what is a fiscal month. Now, I'm telling, if I say fiscal month is 1, all over the world, is it 1? For example, I go to America, US. America, let us understand the financial calendar. The fiscal month is not the same as 1, because in India, it is the first month. Financial first month is, this one means April. Okay. So, according to, according to calendar quarter means this will be quarter 1 and quarter 1. This will be quarter 2, right? According to our financial calendars. But according to the fiscal calendar, fiscal month is this. And in India, what is the fiscal quarter? Fiscal quarter according to India calendar I'm talking about. Okay. So when is the first quarter? Financial quarter. Financial quarter 1, 2, 3. This is the quarter 1. This is the quarter 1. This is the quarter 1. So Jan, Feb, March, June. This is the quarter 1. So it is not same as this or this. It is not same as this. Okay. But calendar month everywhere the meaning is the same. So if something is same all every time means that kind of a table is called as a conformal dimension. If it is not equal everywhere, if it is not calendar, if it is not same as everywhere, then this is not a conformal dimension. For example, I have to create a dim timetable underscore India, dim timetable underscore Pakistan, dim timetable underscore US, because they will have different time zones. They will have different this one. So I cannot say this is a conformal dimension. Everywhere the meaning is not the same. Or you may use, dim dim calendar timetable or dim fiscal time. So fiscal time will be something else. Okay. So when you say meaning everywhere same means, if I say January, in India also 1, in America also 1, in Iraq, Iran, everywhere it is 1. So meaning will not change. If the meaning changes, then definitely this cannot be conformed dimension. Clear? If I go to America, the calendar month, so they may be starting month of, let us say, September. For them, it is first month is this, second month is this, third month is this, like that. Okay, then fourth month. So the fiscal calendar, fiscal quarters will change, depends upon the country to country. Fiscal calendar is something different and the normal calendar month is something different. You will see fiscal month number, calendar month number. According to the country to country, this will change. Calendar month is one, but according to India, the calendar, financial calendar is 10 here, January, right? So quarter number is 1, 2, 3 here. But you see, what is the quarter one? Financial quarter one means April, May, June. So the meanings will change. When the meanings are changing, that is not a conformed dimension. Conformed dimension means everywhere same meaning, right? So that is the point that you have to speak about it. So, like any day, not only the dim time table, any dimension table, the meaning is the same here. The meaning is also same there. For example, I have a dim location table. If I'm saying Hyderabad here, it is belonging to India. If I'm saying Hyderabad here, it is belonging to Pakistan. So what happens? The meaning is not the same, because we have one Hyderabad here, we have one more Hyderabad in Pakistan also. When I say Pakistan, for me it is India. For Pakistan, citizens, for them they have their own Hyderabad. So the meaning is not the same. When the meaning is not the same, so this is not a conformed dimension. Clear? If I'm saying America, it is America for everybody. If you're saying America, it is for America for everybody. The country name does not change. We have only one country, entire world, right? So that is the point. The name should not, the meaning should not change. That is what is the conformed dimension. Especially, you have to have multiple fact tables. Then only this occurs. Otherwise, it is not going to occur. So, dim timetable is a common conformed, because January, February, March, April, these numbers will not change in any country. What will change? The financial calendars will change. So, financial calendar cannot be a conformed dimension. A normal, calendar month, calendar names will be the conformed dimensions, because these values will not change, meaning will not change. That is the point. Conformed, very, very, very important question. Role playing is also very, very important question. The next question is, what is a junk dimension? It's very, very interesting. Compulsory interview questions, all these are. What do you mean by junk? Junk dimensions are used to reduce the number of dimensions in the dimensional model and reduce the number of columns in the fact table. It will help us to reduce the size of the fact table as well. So this is what is the beauty, and lot many things we need to understand carefully. Okay, read this slide once again. Junk dimensions are used to reduce the number of dimensions in the dimensional model. Why we need to reduce number of dimensions? If you create more and more dimensions, more joins means reading will be slow. When the reading is slow, the data warehouse will have a lot of performance issues, right? So the day number one, I told you, you have to reduce number of tables, especially number of dimension tables you need to reduce. So if you wanted to reduce, one technique we have used, denormalization concept, right? Take two tables and reduce it. Two take tables and merge it. Take the three tables and merge it. Take two tables and merge it. One concept already applied. That is what is called a denormalization technique. Take two tables and merge it. The next technique I'm going to be applying, junk dimension technique. Okay. So let me give you this. And reduce the number of columns on the fact table. So reduce the size of the fact table. Okay, now one more thing you need to understand. What does a fact table contain? Already we discussed. Fact table should contain only foreign keys plus facts or measures. Less number of columns to be there in the fact table. That is also one more important point you should understand. Now, let me go back and go to my OLTP. Let us understand one situation now. I have a sales table. Sales table is having customer ID, product ID, date of sales, quantity sold, sales amount. Now, lot of other values also there. I did not show you this, but let me introduce these values. Let me go and add some more columns into the fact table. This is a transactional table. Okay. How the customer made payment, net banking, card, PayPal, cash on delivery, or you can say phone pay, something like this, or Google Pay. So different modes in which the customer has made the payment. Okay, so that is also available in your sales table. Who's the customer? What is the product he purchased? Date of sales, quantity sold, what is the amount he paid, how he paid. Okay, net banking, blah blah blah. Now, in which currency is paid? Because the sales is going on in America as well as in India. So he paid INR, Indian rupees, USD, INR, INR. Something like this. Now, each and every time we have to give the invoice number, bill number. For each transaction, you may get invoice number, bill number. So I have this data, right? Now, if I wanted to take this data, what you need to do? You need to take all this data also and copy this data, move these columns to the data warehousing fact table. Where is my fact table? This is my fact table. Everything is fine till this, right? So I have to go and add these columns there. What are the columns? I need to add it. So these are the extra columns. We never seen it, but I am planning to show you now. So we need to add these values as well. Clear? As part of my fact table. So customer ID has become a customer key. Product ID has become a product key. And we have date of sales has become blah, blah, blah. Everything is fine now. Now, some more columns we need to add. Okay, so some more columns we need to edit. I have added. The same data is also implemented. The first question, what does a fact table contain? Fact table will contain either a foreign key. If it is not a foreign key, it is a measure. It is a measure. So the next one is what? It is a foreign key. It is a foreign key. Is it a foreign key? Is it a measure? So if it is not a foreign key, it should not be in the fact table. That is the rule number one. It should be either a foreign key or it should be a measure. But is it a foreign key? No. Is it a foreign key? No. Is it a foreign key? No. If it is not a foreign key or not a measure, it should not have that. So what we need to do? We have to create lot of dimensions. So how to create a foreign key is you know, right? So creating a foreign key is very, very simple. Now for this column, you have to create one dimension table. The dimension table is this. Pay mode key and mode. So you're going to be writing all of them. One is net banking, two is COD, three is card, five is PayPal, something like this. This one is phone pay, all the payment modes, all the dimensional payment mode. So payment mode key, 1, 2, 3, 4, 5. This is a primary key. What is the mode of the payment? Net banking, blah, blah, blah. So this is one more dimension table you need to create. So instead of writing net banking there, you take one and you're going to be putting this key there. Let me go. And instead of using this, you're going to be saying payment mode. So net banking is one. This will become a foreign key because it is going to be point. Next one is card. Card means what number? You have to come here. Card is number 3. PayPal is 4. Card is number 3. PayPal is 4, right? Card is number 3. Card is number 3. PayPal is 4. And the phone pay is 5. Cash on delivery, something like this. What is cash on delivery? COD. Okay. We have a COD. Where is COD is here? COD is a 2. So you go up. You have implemented it to somewhere to it is better. Okay, so what is happened now? Because of one rule. What is the rule? You should not have any other column other than foreign key or the measure. So, according to that knowledge, you created one more dimension table. But according to our instructions, reduce the number of dimension tables. Okay, according to the day one we are discussing, reduce the number of dimension tables. Now I have created one extra table. So understand this point. Okay. Next, come to the next point. What is the next point I'm having? So I have a foreign key. What about this currency? Currency is a dimensional data, but it is available here. So I should not have it. I have to create one more. I have to create one more table called dim currency table. So it is a primary key 1 and a 2 and INR USD. So I have to take this currency key. INR means 1. You need to go and you have to take this and convert this as a foreign key. INR is 1. This is a 2. This is a 2. This is a 1, 1, 1. Right? So it is also converted as this. Now I have to create one more dimension table. I have created one more dimension table. We are saying other side reduce number of tables, and one side we are increasing the table by table, table by table. Why we are increasing? Because not foreign key, factor table should not have any other data other than foreign keys and measures, right? It is a foreign key, fine. It is a foreign key, fine. It is a foreign key, fine. It is a measure. It is a measure, fine. It is a foreign key, fine. It is a foreign key, fine, right? So you are following the proper instructions because a factor table should contain either a foreign key or a measure. Other than that, it should not contain anything. So you are remembering that rule and keep on creating lot of dimension tables, right? So there are two problems here. One is number of dimension tables also getting increased, right? So can I do something here? So, and one more point, can I reduce number of tables, number of columns in the factor table? Because you understand like this, a table, for example, you have a factor table, fact tables with, let us say, 100 columns, and fact sales table with the 50 columns. Because what you cannot reduce in any table, rows you cannot stop it, because every day 50,000 transaction, 1 million transaction, 2 million transaction, rows can't be controlled, because every time you need to load the data. But what you can control, number of columns you can control. You have 100 columns here, rows every day. If you have 100 columns and every day you're inserting 50,000 rows, okay, so you have control number of columns here, and rows you cannot control. So every day you are having 50,000 rows. So this table size will become bigger. This table size will become smaller. Why? Because rows you cannot control, but you can control the columns, right? So when we have less number of columns, the table size will be less size table, and this is bigger size table, right? So large size table when you have more and more columns, because fact table you cannot control the number of rows, but you need to compulsorily control number of columns, right? If you increase more and more columns in the fact table, the size of the fact table will increase a lot, right? So try to reduce number of fact tables. All these are best practices to create a data warehouse. Best practices, best design concept, or best rules, we can say. The first rule I told you, reduce number of dim tables. Okay. The next concept, always apply denormalized concept. That is reducing only, right? concept. The third one I'm telling you now, very, very important point. Reduce number of columns. Reduce number of columns in fact tables, especially. Why? Because the fact table sizes are more. Because every time sales is heavy, if you have a bigger, columns, more number of columns means more number of rows will get added. The table size will get increased a lot. If the table sizes are more, definitely you're wasting a lot of space. Clear? So reduce the number of columns. So how do I do that? So two problems. I have created lot of dimension tables, and I have also got more number of columns are also getting increased. So I am planning to remove these two, and I'm planning to give a new solution. So two dimension tables got added, two new columns got added. So I wanted to give a beautiful solution to this. So what is a beautiful solution I can give? Like this. Instead of creating two dimension tables, so instead of me creating two dimension tables, so I don't want to create this table. Delete it. I don't want to create this table. Let me delete this table as well. Okay. Create only one table like this. So what is the table I'm creating? Pay mode and currency. Net banking INR, net banking USD. Cash on delivery INR, cash on delivery USD. PayPal INR, PayPal USD. Card INR, card USD. I am creating only one table and putting all combinations, right? So what is the one? One means you're paid net banking INR. So instead of having two tables, I have created only one table. This table is called as a junk dimension. Clear? This table is called as what? Junk dimension. It is not at all needed, but I don't want to create a two tables, because reduce the number of tables is always good, right? Now, instead of creating two tables, all the data I experimented like this. Now, sales details key, this key I wanted to implement it here. Instead of having two columns, I will remove this two columns, right? Have only one column. What is the one column? Sales detail key, something like this. You can give any name. And this is a foreign key. This is a foreign key. Now let me go to OLTP. What is the OLTP says? OLTP first transaction says it is a net banking INR. So net banking INR means what? You come here. Net banking INR means what? So I have to go and put one. So earlier you had currency is one, and earlier you had payment mode is one. Two columns are there. So this we applied. Reduce number of columns in the factor table. Two columns I don't need now. One column. The one column is clearly telling me one. What is a one? One means very clear. It is net banking INR. Let me go to the second transaction. What is it? Card USD. Let me go here. Card USD. It is a number 8. So I have to go and give the 8 here. So 8 means what? Card USD. So only one number it is telling me 2. Okay, it is one number. It's telling me card and USD. So that data. So number of tables are, earlier it was 2. Now instead of two tables, I have reduced one table. Clear? By combining two table data into one table data, I got lot of combinations. You have 1, 2, 3, 4. 4 into INR USD, total 8 rows you can get it. If you have 5 into 3, 15 rows you will be able to get. You may be having more data here, but it is useful. This is what is called junk dimension. So junk dimension will enable us to reduce number of tables. Two table data again I merged into one table. The concept is called denormalization. Two table data, currency data, payment mode data, I have reduced it here. Send. This is a denormalization concept. And because I have reduced, number of columns also got reduced. Earlier we had two keys, right? Now you have only one key. So this is what is called a junk dimension. Very, very, very important interview question. Am I clear, guys? So this is what is the point that you got to understand. If you have any questions, you can ask me. I have unmuted. Am I clear, guys? What is junk dimension means? Okay. Now, if you don't have anything, that is fine. So that is what is called junk dimensions. Very, very interesting point. Junk dimensions are used to reduce the number of dimensions in the dimensional model and reduce the number of columns in the fact table. It will help us to reduce the size of the fact table as well, because two columns means extra millions of data you need to have in that column as well. Okay, so that is the point that you need to understand. Now, what does a fact table contain? It should contain only foreign keys and facts or measures. Lesser number of columns to be there in the fact table. Creating a fact table with more and more columns is always dangerous. Clear? Remember. The next point, degenerate dimension. The next one, so in our this one, junk dimension, degenerate dimension. Let us understand what is this. A term degenerate dimension was originated by Dr. Ralph Kimball. It's a describing dimension field in the fact table that does not have a corresponding dimension table. Placing these text attributes will slow down the performance of the fact table, but we cannot help it. So what is the meaning? Meaning means I go and I take the next column. What is the next column? We have a column called a bill number. Okay. So I have taken this, I have taken this. I should also take this. Let me go and place the bill number here. Okay. I have taken and adding the bill number. When I'm adding bill number, one rule I'm missing. What is that rule? Foreign key should contain, fact table should contain either foreign keys or measures. It should not contain any other data. It is a foreign key, fine. It is a foreign key, fine. It is a foreign key, fine. It is a measure, fine. Measure, fine. It is a foreign key, fine. Foreign key, fine. Foreign key, fine. Is it a foreign key? It is not a foreign key. Is it a measure? It is not a measure. It is not a measure. It is a foreign key. Then what is this? This is what is called dimensional data. If it is not a measure and it is not a foreign key, then what it is? It is a dimensional data only, right? It is a dimensional data. Dimensional data, you should not keep it here. So you have to either maintain a foreign key or you have to maintain. So if you wanted to maintain a foreign key for this, you have to create one more dimensional table called dimension bill numbers. So I have to create bill number. All the bill numbers are like this, and I will have a key, bill key 1, 2, 3, 4. Now I have to take this. I have to take this and I have to put this bill key. Now it will become a foreign key. It may be 1, it will may be 2, something like this. I can have it. Okay. I can create like this. Now it is a foreign key, that's fine. But the problem, I have increased one more dimension table. Reduce number of dimension tables, I'm telling, but now I am increasing one more table. So that is dangerous, right? So don't increase. So what Ralph Kimball says, don't create like this. Keep the data like this only. What kind of a data it is? It is a dimensional data. It is not a fact data. It is not a fact data. Fact data means either it should be a foreign key or it could be a measure, but it is not that. It is a primary key value. That is fine. It is a primary key value, but it is a dimensional data. Clear? But dimensional data staying with whom? Staying with fact table. So it is what is called as a degenerate dimension. Remember this. Okay. So what is a degenerate dimension means? It is a dimensional data living with fact table. It is not a dimension. Dimension means a table. Clear? It is not a table, it is a column. So dimensional data which is available in the fact table itself, leave the data as it is. Don't create one more dimension table. You leave this as it is. Bill numbers, invoice numbers, some flags you may be seeing as part of your fact tables. So this is what is called as a degenerate dimension. It is not a table which is a column. It is a column. But what kind of a data it is? It is a dimensional data, but it is stored as part of the fact table. What does the fact table contain? Compulsory interview question. Facts and measure plus degenerated dimensions. Okay. So the textual data, or you can say dimensional data, which is available. This is dimensional data. Dimensional data, but stored as part of the fact table. So that is what is the degenerate dimension. The term given by this fellow, dimension field, a dimensional field in the fact table that does not have a corresponding dimension table. Placing these text attributes will slow down the performance of the fact table, but we cannot help it. Voucher numbers, bill numbers, blah, blah, blah. Clear? So you don't have corresponding dimension table. This is the dimensional data placed as part of your fact table. That is what is the slowly changing dimension. Okay. So tomorrow we'll talk about rapidly changing dimension and very, very important, slowly, rapidly, inferred. These three I will discuss tomorrow. And if you have any questions, you can ask. Today we completed role playing and we confirmed what is the role playing. If any dimension table and fact table is having more than one relationship, means the dimension table is called as a role playing dimension. Confirmed means the meaning of the column value should not change. For example, the calendar year, calendar month, blah, blah, blah. Junk dimension means don't increase many number of dimension tables and don't increase many columns in the fact table. To create, we are going to be creating a bridge table. So many people will say junk dimension is also called as a bridging table. Bridge table, people will be calling this as. Okay. So remember that point. Okay. You have to create a bridge table by combining this. This is junk table, or you can also call this as a bridge table. Clear? By creating a bridging table, we can reduce the number of columns here, and we can reduce, individual dimension tables. Okay. So why junk dimension means you have to tell what is the answer. Why junk dimension means to reduce the number of dimension tables and to reduce the number of columns in the fact table, we use a bridge table. The bridge table is also called as a junk dimension. Junk table. Clear? It is not going to come from the OLTP. OLTP, you don't see this kind of a table. That is what is my point. Okay. The next one is, what does fact table contain means foreign keys, measures, and one more thing it is going to be containing. Now that is what is called degenerate dimensions. Okay. Degenerate dimensions also it is going to contain. And remember, lesser number of columns to be there in the fact table, because if you increase more columns, because you cannot control number of rows. So when you don't control number of rows, at least control number of columns. Okay. Having 99 columns and having 95 columns, definitely you see the big difference. That is what is the point. Clear? So degenerate also we discuss tomorrow. Slowly changing dimension, inferred dimension, rapidly changing dimension, everything we'll discuss. What is summary? Conformed is something which can be shared by multiple fact tables or multiple data marts. Junk dimension is a grouping of flagged values together. This is also called as a bridge table. Degenerate dimension is something dimensional in nature but exists in the fact table. Clear? So what are the best practice of data warehousing to design? Reduce the number of tables in data warehouse. study fully OLTP, study reporting requirements, proper relationship, reduce number of columns in the fact table, reduce the size of the keys also, have a junk dimensions, have a degenerate dimensions, blah, blah, blah. Clear? Reduce number of which tables? Reduce number of dimension tables especially. Okay? So that is what is the best data warehousing principles and practices. We'll continue tomorrow with some more things. Clear? Any other questions?
Hello.
Yeah.
Sir, according to a degenerated dimension, it means we can store dimension data in a factor,
Yeah,
but it
that
is
is the
called
meaning.
degenerated.
Yes,
And
that is the meaning. Correct.
and it's not possible to suppose we don't have a dimension table, just like a bill table, bill generated, and only I can insert a bill number in a fact table, but data is just like a dimension data. But I don't have create. I don't need to create a, dimension table.
That's what I told you, right? After our discussion, only that I told you. Yeah, correct. Whatever you're saying is correct. You need not create a corresponding dimension table and simply leave the data as part of the fact table itself. Yeah.
Hello, sir.
Yeah, tell me.
Sir, if some dimension contains like composite primary key and that let's say two columns containing like combining creating primary key, so that two columns would be available in the fact table as well, right? As a foreign
Yes,
key.
yes, yes. All these are degenerate dimensions. Yeah, it is available. Yes, it will be available.
So that so it means it has more than one relationship with your dimension table, right? So will it called as a role playing dimension?
No, that is not a role playing. Role playing means two foreign keys you need to have, because when you have a composite primary key means it is a key which is having two columns. But I'm talking about two foreign keys. I'm talking about not two columns in the composite. Okay. So composite primary key is not going to create a two foreign keys. Composite, either one primary key will create one foreign key only. Clear? Even though you have 1,000 columns in the composite primary key, still you will be able to create only one foreign key. Second time when you're creating, so that is a second foreign key. Clear?
So
You know,
so when we have multiple like composite key as a primary key in dimension table, how it will linked with fact table? Like you will create one more column as a primary key and then you will link with fact.
yeah. Because I'll show you one example. I have a table here. Okay. I have a table called customers table. Okay. So customers are having a tower number and house number. So I am purchasing a house number. And what is the customer name? And what is the customer phone number? Something like this. So to identify me, tower number A, I have given this example. House number 1, where Ajay has purchased this house, and some phone number. Tower number A, house number 2, say Peter is owner of this house, some phone number, right? So like that, A1 to 100. Again, you have B1, some Joy is purchased this. Again, you see B2, like that. You have a lot of towers. In each tower, you have A1, A2, A3, A4, A5, A6. Now, what is the primary key in this? If you take this is a duplicate, if you take this is duplicate data, so what is the primary key in this? The primary key is this composite primary key put together. So this is a composite primary key, right? So two columns put together is going to be playing important role. This is a primary key, but especially which is a composite primary key. Why? A primary key is having two columns. Because to identify single Ajay, I have to tell Ajay is available in tower number A or house number 1. If I say only house number 1, I will not be able to get this guy, because house number 1, this Ajay and Joy, and here we have Sita also there, like that. Now, tomorrow, whatever be the reason, these people have purchased and they have given for the rental. So you're also maintaining a rental amount. So this is a fact rental amount you're maintaining, right? So every month you're going to be getting the rental amount. So you have to maintain what is the tower number and what is the house number. Clear? And date of payment. So paid date and what is the amount you have received. This is the fact table. Now, so this is a composite primary key. This is a foreign key which is going here and getting the data. For example, you maintain a foreign key, one foreign key only it is, but it is talking to this. Now you say A2 has paid. When is paid, let us say 12th December 2020, he paid some payment. How much? $10,000 he paid. What is the meaning? Meaning is it is a foreign key, but dealing with this, it is not two foreign keys, it is only one foreign key. It is not two foreign keys, right? So A2 has paid the amount. Then B1 has paid the amount on some date, some 5,000. So this data is linked here. Clear? So you cannot say it is not two primary keys, it is not two foreign keys, it is only one foreign key, and this is also one primary key, but unfortunately they have two columns. That's it. Am I clear?
Yes, yes. It would be treated as a one relationship.
Correct.
Okay, sir.
Hello.
Yeah, tell me.
Good morning, sir. This is Satish.
Yeah.
సార్ ఫ్యాక్ట్ టేబుల్లో ఈ డీజనరేట్ కాలమ్ ని యాజ్ ఇట్ ఈస్ గా అట్లాగే వదిలేస్తున్నాం కదా సార్.
అట్లాగే వదిలేయాలి. You need to leave as it is. Don't change anything.
ఓకే సార్, బట్ ఫ్యాక్ట్ టేబుల్ అప్లికేషన్ వచ్చేసి దెన్ వీఆర్ ఫ్యాక్ట్ టేబుల్ లో వీ కెన్ మెజర్ ద కాలమ్స్ అండ్ వీ కెన్ అనలైజ్ ద డేటా. దట్ ఈస్ ద మెయిన్ డిపెండింగ్ ఆన్ ద ఫ్యాక్ట్ టేబుల్ సార్.
Correct.
సో సపోజ్ ఇఫ్ ద డీజనరేట్ కాలమ్ యాజ్ ఇట్ ఈస్ గా ఉంచేస్తే అప్పుడు మనకి దాని మీద ఏమైనా అప్లికేషన్స్ చేయడానికి ఎటువంటి ఛాన్సెస్ ఉండవు కదా సార్.
Tell me clearly, what is the meaning of that?
Suppose
if you keep the bill number, what is the problem? If you keep the bill number yet, what is the issue you have?
అంటే ఏం లేదు సార్, జస్ట్ ఎప్పుడైనా రేపు పొద్దున్న అప్లికేషన్ అంటే నాట్ ఓన్లీ బిల్ నెంబర్, ఎప్పుడైనా దేని మీద అప్లికేషన్ చేయాలి అంటే అనలైజ్ చేయాలంటే ఇంకా కాలమ్ ని యాజ్ ఇట్ ఈస్ గానే ఉంచేస్తాం సార్, దాన్ని మాత్రం కన్సిడరేషన్ లో తీసుకోం.
Yeah, this is just leave it as is because you're going to be analyzing data on the measures always, kada.
ఓకే,
You can leave this, there's no issue.
ఓకే, ఓకే.
Yeah.
అంటే ఎప్పుడైనా డీజనరేట్ కాలమ్ సపోజ్ ఇఫ్ దే ఆర్ ఎగ్జిస్టింగ్ యాజ్ పార్ట్ ఆఫ్ ద ఫ్యాక్ట్ టేబుల్, దెన్ we cannot do any analyzation on those columns.
Yeah, you cannot do anything on it. You cannot do anything. Yeah, that is for sure. But the information is needed. For example, I wanted to know what is the bill number for this guy. So for that purpose, I should be able to have it.
ఓకే, అంటే ఏం లేదు సార్, రేపు పొద్దున్న నార్మల్ క్వశ్చన్ సపోజ్ మీరు డీజనరేట్ కాలమ్ అట్లా వదిలేస్తారు కదా, ఫ్యాక్ట్ టేబుల్ లో మెజర్స్ ను ఫారెన్ కీసే ఉంటాయి కదా, నాట్ మోర్ దాన్ దట్ వీఆర్ హ్యావింగ్ ఇన్ ద ఫ్యాక్ట్ టేబుల్. సపోజ్ ఇఫ్ యూఆర్ హ్యావింగ్ ఏ డీజనరేట్ కాలమ్ ఇన్ దట్ వన్, సో వాట్ ఈస్ ద యూజ్? సపోజ్ ఇఫ్ దే ఆర్ ఆస్కింగ్ లైక్ దట్,
what is the use means you will know that the bill number is this. To identify, you need to have a foreign key or you need to have the data. So you need to maintain the data, right? So
Yeah,
either
right.
you can maintain the data by creating a dimension table, that is headache. So I want to maintain here because tomorrow I wanted to know what is the bill number for this transaction.
రైట్. ఓకే,
So what do you say then?
then we will go to the degenerate column and then we can extract the data.
So somewhere there will be use.
Oh, okay.
Yeah.
Thank you.
Very good. Yeah.
So this question is also related to degenerate dimension.
Yeah.
As per proper model, we have to keep it in the fact table. For some reason, if the architect or for some reason they are deciding to keep it in the dimension table itself, is that
Mhm.
okay, or any performance impact?
But it is not necessary.
Your
Even though you
thoughts?
keep and create one more dimension table and link, it does not work. So
Sir, your voice is very low.
that, yeah, people will not do that. Simply they leave like this. Okay, yeah.
Sorry, sir, I lost you. I could not hear you. Can you
Yeah,
repeat,
I'm
please?
saying people will not create one more dimension table. Creating a dimension table is dangerous, right? So they don't
Yes.
create like that and they'll keep like this only. So this will be
Okay.
degen. This is the best practice actually.
Okay. For example, sir, I'm having the sales table where I keep all the dimensional related sales information. Along with that, can I keep this bill number or invoice number?
Yeah, if you can keep as part of the junk tables if you have. Okay, if you wanted
Okay.
to keep something there, you can keep it there. So that is your choice. Yeah.
Okay. Okay. Okay,
Otherwise,
sir.
also you can leave like this. That is also no
All
issues. Yes.
okay. Thank you so much, sir.
Very good, guys. Hope you're following the classes very well. Hmm? Let me.
Because of your presentation, sir, we are following.
Okay, good, good, good. Thank you.